Hello there, trigonometers or pre-calculus students who are doing trigonometry as part of pre-calc. In trig, which is one of the main things we do in pre-calc, there are a lot of identities, basically statements about trig functions that are true. And one set of those is the sum and difference identities, which look like this. Okay, now, the main thing we use these for is when we have when we have an angle that we are trying to find the sine or cosine or tangent of, and it is an angle that is not a unit circle value. Like, for instance, 75 degrees. 75 degrees is not one of the things we memorize on the unit circle. But 75 degrees is the same as 30 degrees plus 45 degrees. And 30 degrees and 45 degrees are both unit circle values. So that's just a very simple example of one of the main uses of these. But like with everything else, we tend to be asked a lot of other questions about how to deal with them as well. So let's just do a few problems here. These are problems on my pre-calc students' Unit 4 test review. And I'm going to start with their number 2. Looks like this. Now, these can be in degrees, which these particular problems happen to be, or really it's probably a little bit more common that they'll be in radians. All right, either way, 135 degrees, which would be 3 pi over 4, and 240 degrees, which would be, 4 pi over 3. Those are unit circle values. Those are things that we know the unit circle value for. So the biggest thing not to do is not to look at this and go, okay, so that's cosine of 135 plus cosine of 240. This is not distributive property. This is not true. We cannot do that. That's why we have these formulas. We have to use these formulas. Okay, so this is a sum because there's a plus and it's a cosine. So I'm going to use this particular formula right here, which you notice does not look like I'm distributing. All right, so cosine A times cosine B minus sine A times sine B. And this is my A and this is my B. So let's take that off. So this is going to be cosine 135 times cosine 240 minus sine 135 times sine 240. Okay, so these are values I actually can figure out. I know that the cosine, let's just think about 240 and 135 for a second. Let's go ahead and just mentally figure out where those are. 135 is halfway between 90 and 180. Okay, so that has a cosine of negative square root of 2 over 2 and a sine of positive square root of 2 over 2. Then we have we have 240 as the other angle. We've got cosine and sine of both of them. 240 is right down here, 60 degrees past 180. Okay, so that has negative 1/2, negative square root of 3 over 2. So those are my coordinates there. Okay, remember that your first coordinate is the cosine and the second coordinate is the sine. So it's not a bad idea, unless you know your unit circle real well off the top of your head, to go ahead and go to the side and jot down what are my cosine and sine of 135, which is what this is, and what are my cosine and sine of 240, which is what this is. Okay. And remember, this would be the same if it was 3 pi over 4, and this is the same as 4 pi over 3. All right, so I'm going to do the cosine of 135, which is negative root 2 over 2, times the cosine of 240, which is negative 1/2, right here, minus sine of 135, which is positive root 2 over 2, times sine of 240, which coming back down here is negative root 3 over 2. Now, because the unit circle values they repeat with different signs, basically, because we see the numbers square root of 2 over 2, 1/2, root 3 over 2, 1, and 0 all the way around the unit circle. When you do the sum and difference formulas, you end up a lot of times getting some of the same numbers, maybe just slightly different configurations. So if you do several of these problems and you keep bumping into some of the same numbers, like for instance, here we have square root of 2 on top and 4 on the bottom. And over here we have negative square root of 6 on top and 4 on the bottom. You'll run into square root of 2 and square root of 6 a lot doing these. So that's square root of 2 plus square root of 6, both over 4. You can write it like this, or you can rewrite it as one fraction with a common denominator. Both of those are correct. All right, moving on. Next one is not already broken up like this one was for us. The next one says find the sine of 165. So this is a perfect example of what I was talking about a second ago, that we have a number here that is not on the unit circle. This is not a number. I haven't memorized off the top of my head what the sine of 165 is. So instead, I have to think about it in terms of what two numbers could I add or subtract to get 165, where both of those numbers are numbers that are commonly used on the unit circle. So for instance, the first thing that comes to mind is 120 plus 45. Okay, but we don't have to, let's see, I'm going to need to come up with a different example here. We don't have to use a sum. We could use a difference. Let me see if we can come up with a good difference here. How about sine of 210? Excuse me. Minus 45. You don't always have to use 45. But would that work? I think that would not work, actually. Yeah, it would. Okay. There we go. So either one of these would work. Anything that either adds up to or subtracts to make 165 with two different numbers, where these are unit circle values. So that's why I chose these. I wouldn't choose, for instance, sometimes I'll have students do something like this. Say, oh, okay, I'm just dividing that up. That's sine of 130 plus 35. Well, yeah, it is sine of 130 plus 35, but neither of these is a unit circle value, so that doesn't help me at all. So I would not do that. So I'm just going to go ahead and go with the first one. And I'm going to use that sum of sines, or sine sum formula. The sine of a sum is sine of the first thing times the cosine of the second thing, plus the cosine of the first thing times the sine of the second thing. Okay, so I'm going to use this, where my first number is 120, my second number is 45. So this is sine of 120, times cosine 45, plus cosine of 120 times sine of 45. All right, now thinking about 120 and 45. 120 is right up here. It's the same thing as 2 pi over 3, and its coordinates are negative 1/2 square root of 3 over 2. This is the cosine, this is the sine. The other angle we're dealing with here is 45, right in the middle of the first quadrant. It's over square root of 2, up square root of 2. It's 45 right there. So that's square root of 2 over 2, square root of 2 over 2, or root 2 over 2, root 2 over 2. And again, this is the cosine, and this is the sine. So you really either have to know these or have your unit circle handy so that you can come up with them quickly. So sine of 120 is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 120 is negative 1/2. Sine of 45 is square root of 2 over 2. And I have square root of 6 over 4 plus negative square root of 2 over 4, or root 6 minus root 2 all over 4. And that's my answer. Okay, I'm going to do some more examples in another video. Hopefully these have helped so far, and I'll be able to give you some more that help you. Thanks for watching.